Welcome to Homework Lib.
In number 4, part A, we want to construct a 95% confidence interval. To do that, that's the sample mean plus or minus a critical z times the sample standard deviation over the square root of the sample size. So we know our sample mean is 7.2 plus or minus a critical z at 95% is 1.96. The sample standard deviation is given as 1.8. And the sample size is 100. So our lower boundary comes from subtracting 7.2 minus 1.96 times 1.8 over the square root of 100, which is 6.85. Just say 6.85 to an upper boundary of 7.55. Interpreting it would mean that with 95% confidence, we can say that the true population mean, again, the true population mean of the number of bits of information people can store in their short-term memory falls within the range of about 6.85 to 7.55. In number 5, does the central limit theorem apply? Well, it applies when you have a large enough sample size, typically greater than or equal to 30, and when the sampling distribution of the sample mean tends to be approximately normal, regardless of the shape of the original population distribution. So in this case, we have 400 men, which is sufficiently large. So yes, because n equals 400, which is greater than or equal to 30. What minimum sample size is needed for it to occur here? Well, that would be calculated as the square root of the sample mean, or not the sample mean, but the population proportion, times 1 minus the population proportion over n. I'm just going to call this P. And since the population proportion is 6.6%, I didn't realize I was actually starting to answer C here because this is B, 30. So at any rate, we want to find the probability that less than 6.5% are affected. And so we need a z-score for 6.5%. And that would be 0.065 minus 6.6%, so that's 0.066 over the standard deviation, which is going to be the square root of 0.66 times 0.066 times 1 minus 0.066 over 400. Which is negative 0.081, and that probability is 0.4677. And if we take samples of 400 men, what sample proportion would be the 4th percentile? You would need to use the standard normal distribution table or calculating the z-score associated with the 4th percentile, and that's about negative 1.7507. And so if we use the z-score formula, that would be negative 1.7507 equals, we want to find x. And so if we solve this, we get about 0.0443, which would be like 4.43%.